Hi there. What we've got here is another circuit problem. Okay, so this one reads a capacitor discharges through a 770 ohm resistor. The charge on the capacitor is reduced to half its initial value in 8.5 milliseconds. The initial voltage across the capacitor is 6 volts, and we want to know what is the capacitance of the capacitor, and we want to find the initial charge on the capacitor. Okay, so this is an RC circuit, right? It's got a resistor in it, it's got a capacitor in it, okay? We've got a couple of different mathematical descriptions of RC circuits. We've got one that goes Q is equal to capital Q 1 minus e to the minus t over tau. And we've got another one that just goes Q is equal to capital Q times e to the minus t over tau. Okay. The difference between these is that this one, okay, the first one here is for a capacitor which is charging. In other words, we're putting charge on the capacitor. This is one where it's discharging. In other words, the charge is leaving the capacitor. And in this case, we're told in the problem that the capacitor is discharging. And so it's not this one that we're going to use. It's this one. Okay? So this is our mathematical description of our circuit. Now let's see how we can use this to figure out what we want to figure out. Let's see. We're told that the charge on the capacitor is reduced to half its initial value in 8.5 milliseconds. Okay? So here's what that means mathematically. Okay? It means that when small q is equal to 1/2 of capital Q, that's when t is equal to 8.5 milliseconds. So let me put that in. So small q, that's the charge on our capacitor, is equal to 0.5 times capital Q, because Q is the initial, in this one, is the initial value of our charge. Okay? In other words, it's the maximum value. Over here in this other one, for a charging capacitor, capital Q is the final charge. Okay? So, Q, the charge on our capacitor, is equal to 0.5 times capital Q. That's equal to Q times E. And when small q is equal to this, T is equal to 8.5 milliseconds. Okay? And notice that what this allows us to do, okay, we've got a Q on both sides. We can cancel those. And so we've got 0.5 is equal to e to the minus 8.5 milliseconds divided by tau, okay? And notice we should be able to solve this for tau then, because we know everything else, okay? Now, of course, tau is up here in the exponent, and remember that the way that we get to this exponent is we first get the exponential function all by itself. That's actually done for us, okay? It's all by itself right now, okay? And then once we've got the exponential function all by itself, we take the natural logarithm of both sides. And so the natural logarithm of 0.5 is equal to, and basically what the natural log function does over here is it undoes the exponential, and so we just have minus 8.5 milliseconds divided by tau. Okay? And that means that tau is equal to, let's see, 0.0085 seconds. That's what 8.5 milliseconds is. Okay? Minus, divided by the log of 0.5, which is minus 0.693. And this tells us then that the time constant of our circuit is equal to, let's see, 1.59 times 10 to the minus fifth. Whoops. Sorry, I'm reading the wrong thing on my paper here. Tau is equal to, where'd that go? There it is, 0.0123 seconds. Okay? Now that's not what we want to find yet, but that'll get us closer. We're after the capacitance, and remember, the time constant of a circuit is related to its capacitance this way. Okay? Tau is equal to R times C. All right, and so what that means is that now that we have the time constant, and of course we've got the resistance of our circuit, we can figure out what the capacitance is. So I can go 0.0123 seconds is equal to 770 ohms times C, and C is equal to, let's see, 1.59 times 10 to the minus fifth. That's where that number goes. Farads. Okay. So that's the capacitance of our circuit. Okay. And that's what we wanted to find in part A. All right. Part B, okay, we wanted to find the initial charge on the capacitor. Okay. What we know is the original voltage on the capacitor. All right, and charge and voltage, remember, are related by our definition of capacitance. Remember that the capacitance of a capacitor is defined as the amount of charge on the capacitor divided by the voltage across the capacitor. Okay, and so in this case, I know my capacitance is 1.59 times 10 to the minus fifth farads. Q is what I'm trying to find, and delta V is 6 volts. And this gives me Q is equal to 9.56 times 10 to the minus fifth coulombs. And so that's our answer to part B. And we're done.